If you're terrified of equations of lines, this video is for you. In the first 2 minutes, we'll go over an example, which should help you understand the concept much better. A burrito costs $3 and toppings are 50 cents each. What equation models the cost y per topping x? The goal is we're going to make a table, then use that to build a graph, and use that graph to then create an equation. So our goal is to fill in values of m and b over here. To start, x is topping, so let's start with 0 toppings. We know that's going to cost $3, and then we can use that point on here. Notice 0 toppings is here, then we go up 3 and put a point. But right away, we're already 50% of the way done, surprisingly. That is what's called the y-intercept, or the initial value. Whenever x is 0, whatever y is the number or the value you're going to change b to. Why isn't it y? Well, because there's already a y there, that's why they use b for the y-intercept. It's a little confusing. Now let's just keep adding toppings, because of course we got to have guac, black beans, all the things here. So we add 1 topping, the cost bumps up 50 cents, then we'll add that point. Add another topping, the cost is just going to bump up another 50 cents now to $4, add that point. And then you see the pattern. We're just going to keep adding a topping and the cost increases 50 cents. Because the increase is constant, that's why a line is the model for this. If the costs change, like after a certain number of toppings, if it dropped down to 25 cents, notice the curve would kind of flatten out, but it just keeps climbing at the same rate. That's why it's a line. Now, how do the y values change over here? Right? They just add up by 50 cents. So that is your slope. Whenever x increases by 1, whatever happens to y, it could be negative, by the way, but in this case we're adding, so it's positive, and that is the slope. That's the whole equation. You're done. I think that was under 2 minutes. Oh, it was just over 2 minutes. And from here you could then look at the 0.5 more closely. Another way to write that is 1 over 2. You might have heard, rise over run for slope before. So that means from your initial point, always is where you start. If you go up 1, you'll go over 2, you'll hit the line. Or the cost will go up $1 for every 2 additional toppings. Up $1, 2 additional toppings. Another way to use this model is you can change x to anything you want. Let's say you change x to 4. 0.5, or 1/2 times 4, half of 4 is 2. Plus 3 is 5. That's what y equals now. So that means your cost for 4 toppings is $5. And it's a way that you can basically make future predictions. That's why these models are helpful. Alrighty, let's keep looking. Now we're going to do the first example together here, and we're just going to build or graph an equation. You're always going to start with the y-intercept. And that one's easy because it's just somewhere on this line. If it's negative, it'll be down there. Positive, it'll be up there. And that one's positive 2, put a point there. Then we use the 1 over 4. Anything next to x is always the slope. And we go up 1 over 4, and then we put a point. You only need to create 2 points. One of them you're given, that's the y-intercept. And the next point you have to find with the slope. So it's like a little scavenger hunt. Where's the buried treasure? And then we draw a line through those, and that's it. Now, what might this model? Well, it's kind of like what we just did, actually, right? Except you notice how our line is a little less steep. So it's cheaper, and the y value is smaller. So again, it's cheaper. So it could be a hot dog, for instance. It costs $2, but maybe the toppings are 1/4 or 25 cents per topping. So in this case, your cost will go up a full $1 if you add 1, 2, 3, 4 toppings, and then you get there. Okay, feel free to try this next one, but I do want to say one thing. A negative 1/3 is the same thing as negative 1 over 3 for your slope for that one if you want to try it. Now, the 3 at the end, of course, is where we're going to start, and that'll be positive 3. But then, like we said, this is a negative 1 over 3. Here's a little chart that you could use. Ours is negative 1. We'll go down 1, and then 3 positive is to the right. So we'll go down 1 over 3 to the right. Then we put our new point. Then we make a line connecting those, and we've done it. We've graphed this equation. What might this model? Feel free to pause if you want to keep thinking about it. I was thinking with this one, usually notice it's decreasing over time. Usually x is time, like seconds or minutes, and it's going down. So I was thinking maybe we're shoveling the driveway and it's modeling that. We remove 1 foot of snow every 3 minutes, something like that. I got this picture from an article online, and it was actually sadly about how people die while shoveling their driveways. But I appreciated the title. It was called Snow Laughing Matter. And on this page, feel free to pause and then use those concepts to graph these two. Assuming you have, let's jump into it. By the way, bonus for coming up with what these might model. The number at the end is negative this time, so we know we're going to go down below the x-axis. Put that point there. Then we're going to use the 1/2, and it's going to be positive, up 1, over to the right 2, and put our point. Then connect those, and we've done it. We've graphed that line. This one, because it starts underneath, I was thinking it's something that might happen underground or underwater. So maybe this is the height of a whale over time. It starts 2 meters below the surface, and then it goes up 1 meter every 2 seconds. Up 1, over 2. And then it keeps doing that. Notice slope will always do the same thing. It's like stairs, up 1, over 2. So when does it surface? At 4 seconds, right? And then the next one, this is a little sneaky, isn't it? Because there's nothing there. So you're like, I don't know, you didn't tell me if B's not there. Anytime that there's nothing there in math, it's always +0. So that just means we're going to start at the middle, or the origin, at a height of y equals 0. If you have y equals 0 as your height, that point there is called the origin. And then we're going to go up 3. Oh yeah, I forgot to highlight the other one. Up 3. Up 5 over 3 is what I meant. Then put our point. Then This one, I was thinking it looked, in my mind, it looked like a passing route. So I was thinking a wide receiver goes up 5 yards over 3, and then the QB is going to throw along that orange line there to hit him at that spot. Okay, next. Oh yeah, now we could do examples where we have the use of a calculator. So there's a button with the calculator called table or y equals, and you can use that to find all the points that a line goes through. So if you were to graph any of these ones, it'll tell you all the points it goes through, including whether it goes through these ones. So if you're using a TI-30, hit table, and then it'll give you a y equals. You're then going to type in -2. There should be an X button. It's usually XYZ. And then type that, +8, enter, and it should give you a table. Now again, like we said, we're looking for these points. So feel free to try each of these process of elimination and see which ones work. Assuming you have, I'm going to give it away. It's going to be B. Now, you don't necessarily need the calculator for this, but you could just change X to -3. And if you do that, 2 times -3 is -6, plus 4 is -2. So that point works for that one. And similarly, the first number in the parentheses is x, the second one's y, so that's also xy. 2 times 1 is 2, plus 4. 2 plus 4 is 6, and that also matches. So the points, that's kind of the beauty of algebra. They'll work in this, even though it's kind of like moving back and forth between graphing and using an equation and using algebra here. And the last one, feel free to pause and practice with this. Okay, which one has a slope of 2? Not this one, because the slope is the number in front of x, so it could be a, b, or c. But when we plug in x as 4, we want the whole thing to equal -1. That one ends up being c here. So you could do table y equals and look for that point, or you could just plug it in visually without even the use of a calculator. Look for where which one of these ends up giving you -1 when you simplify it, basically. So I hope that this broke things down. I hope this builds a good foundation for you, and give yourself a lot of credit if you are understanding these better. You can see that they could model things, so they have an application for sure, but of course you can also kind of tweak them, and the models may or may not be linear, so therefore this is just a foundation to build off of for other models as well.